Alright, here's the situation. It's getting kind of late in the day. Mr. Kelly needs that hit of caffeine if he's going to be able to function and be a rational human being past 2 o'clock in the afternoon. So, I stumble on down to the vending machine, and I press that button right there, and it occurs to me I should use a color probably other than red. So I press that button right there. I should get a Dr. Pepper. So tell me this. If I get my Dr. Pepper out of there, and it's been a bad day, and I push that button a second time, after putting my money in, of course, and I push that a second time, what should I expect to get out of there? What we're looking at today is classifying a given representation as either a function or a relation, which means, and this should put you on definition alert, that we have to learn what functions and relations are if we're going to determine which a representation is. So let's start with a relation. A relation is any situation where there is a connection between two pieces of data. And we call those two pieces of data a domain and a range. So it could be that there is a connection between a button and a Dr. Pepper, say. Just a thought. It could be that there is a connection between your shoe size and your height. Maybe there's a connection between your age and your weight. Could be anything. So a relation is just any kind of situation where we can connect two pieces of data. We call what we start with, so in this case the button, the shoe size, the age, we call that the domain, and then the other set of data we call the range. We're familiar with domain and range. We've seen those in representations. So representations are always of relations, where we're talking about the connection between the domain and the range. Functions, however, are a specific type of relation. So a function is a relation in which each element of the domain is connected to only one element of the range. So for instance, if I had a function, every button that I pressed on that vending machine would lead to only one outcome. And this makes sense. This is how vending machines operate, right? We'd get upset if they didn't. Every time I press a button, I get the same thing out of it, and there's never any other options. So in fact, we can build pretty much everything we need to understand about a function from a vending machine. Once again, I find a way to make it about food. Just saying. So a vending machine does in fact represent a relation, because there's a relationship between the button that I press and what comes out of the vending machine. There is a connection between an input called a domain and an output called a range. But where a vending machine gets special, and a vending machine, or at least a good one, is in fact an example of a function, is that every time I press one of these buttons, I get the same result. I can put dollar bills in this machine and press that Coke button until it runs out, and all I'll ever get out of there is Coke. If I were to press that button once and get a Coke, and press that button again and a Sprite comes out, I would be pretty upset. The vending machine did not work as I wanted it to, because I want my vending machine to be a function. Every input results in only one output. I can't have a button here that gets me multiple kinds of drinks. So to help you kind of understand the relationship between here, we've got to pull out the old Venn diagram. So let's take something other than food for once. Let's talk about shoes. There's all kinds of shoes in the world, all different types. But a small subset of shoes would be Nikes. So not every single shoe is a Nike, but all Nike shoes, anyway, are shoes. So Nike is a specific type, a smaller subset, if you will, of shoes. Well, we can do the same thing with relations. Relations are just connections between domains and ranges, but functions are a specific type of relation where each element of the domain only connects with one element of the range. So now we're going to look at some examples of this, and we're going to look at examples for most of the different types of representations that we have and kind of apply this definition of a function. So if we have a function, remember our definition is that each element of the domain connects to only one element of the range. Nothing else matters. So let's break this down into its parts. We want to look at each element of the domain. So these three pieces that I've put the box around, those are the things we're concerned with. And then what we want to look at is how many elements of the range each one of these connects with. And if I ever have an element of the domain that connects with more than one element of the range, then my relation is not a function. So 0 only has one connection, so it checks out. 1 only has one connection. It checks out as well. And number 2 has only one connection. So we have 3 places here where it checks out that our domain only connects to one range. So again, break this down into each element of the domain and then look at those connectors. And since each element only connects to one element of the range, we would say that this is a function. And the reason is the definition of a function. Each element of the domain, and pardon my bad writing here, of the domain connects to only one element of the range. And so now what we're going to do is look at other examples of this and see how this definition can get really funky, because it can really fast. For instance, let's take this one. Is this mapping representative of a function? Why or why not? So again, I break it down into each element of the domain, and then I want to look at the connections. So for each element of the domain, does it connect to one and only one element of the range? Well, 5 connects to 6 and 7. There are 2 connections between this domain and range values. So we would say that this is not a function, and the reason is that 5 in the domain connects with more than one element of the range. It connects with both 6 and 7. So this is not a function because a domain repeats with 2 ranges. An example that will test our understanding of this definition quite a bit. We have this mapping in front of us, and so now let's go through and let's just analyze this. Let's break it down into its component parts, and let's see how the definition applies. So first thing, we look at the domain, we look at the range, and you've probably noticed here that there are 2 arrows pointing to this range value. Let's see how that applies. So first thing, for the definition of a function, I want to look at each element of the domain. So that's -2, 0, and 3. And then I want to see how many values from the range that domain value connects to. So -2 only connects to one value from the range. So check, it meets the definition of a function. 0 connects with only one element of the range. Check, it meets the definition of a function. Now notice, they both use the same range value, but as far as our definition is concerned, it doesn't matter. 3 only connects with one element of the range. So every single one of those passes our test for a function. This thing is a function because it meets the definition. Every element of the domain connects with only one element of the range, so it is a function. Even though that range value is repeated, that's quite all right. We can do this as well for other representations of relations. So a set of ordered pairs, for instance, we need to find out if that meets the definition of a function. So if it's a function, every element of the range will connect with one and only one element of the, or element of the domain rather, connects with one and only one element of the range. So let's just start analyzing piece by piece. So I've got 5 in the domain. Remember, the domain values come first. We have to know that in order to be able to test this. So our domain value is 5, and it connects with -4. So I'm going to go searching through this and see if there are any other 5s that connect to a different number. Oh, there's a 5, and it connects to a -2. So I have one value for the domain that's connecting to 2 different values for the range. So this one is not a function because I have one domain value that has more than one range value. So for an ordered pair, or a set of ordered pairs I should say, what we're actually doing is looking for any repeats in the domain. And if I see a domain value repeat with different range values, and here it does it even once more, then I know that that is not a function. If each domain value does not repeat, or repeats but has the same range value, then it is a function. So example 5, we can actually use that same rule that we were looking at for ordered pairs. Is this table an example of a function? Why or why not? We just look at each element of the domain. -4 connects to 0. Let's see if there are any other -4s in my domain. There are not. 4 connects to 4. We look for any other 4s in the domain. There aren't any. -3 to -3. There are no other -3s in the domain. So every single element of the domain connects to one and only one element of the range. So we would say this is a function. And again, our quick and dirty shortcut is to look for any repeated values in the domain. So now we're asked, is this graph a function? Why or why not? And our definition of function has not changed. We are just looking to see if any domain value, that is any x value, repeats with 2 different range values. And so here I can see I have a domain value of -5. Nothing else has that domain value. Here a domain value of -3. Nothing else has that. Domain of +3. No other point has that. Domain of 5. No other point has that. So this is a function. However, there is a nice quick test for graphs that we can use. This test is called the vertical line test. And so remember that what we're testing here is the domain value, so that is the x coordinate for each point, unique? And if that's the case, then no 2 points will be right on top of each other, which means I should be able to take a vertical line, like this red line right here, and scoot it across my graph. Now, if you don't have a nice digital setup with a pre-made red line to slide across this, what you can do is just take your pencil and hold it vertical up and down, and then slide it across the graph. So I, fortunately, have a nice pre-made red line that I can slide back and forth across. So you run this vertical line across the graph, left to right, just like you're reading. And if it ever touches more than 1 point at once, there it's only touching 1 point, 1 point, 1 point, and 1 point. Remember the blue dot, something I just put on there. If it never touches more than 1 point, then we say our graph passes the vertical line test and is a function. If you ever have this vertical line touching 2 points on the graph, then those 2 points have different range values for the same domain, and it fails the vertical line test and is not a function. So here, because the graph never touches the line more than once, we say it's a function. But we can also look at an example where that is not the case. So example 7, is the graph below a function? Why or why not? So I take my vertical line. This only works for a graph. So I take my vertical line test. I run the vertical line across there, and notice that right here, when I have my vertical line right on the y-axis, it's touching both a point right there. In fact, let me draw them in blue so you can see them a little bit better. It's touching a point right there and right there. So those 2 points, if I write out their coordinates, 0, -2, 0, -5, it's the same domain value with different range values. This fails the vertical line test because 2 touch it at once, so we would say that this is not a function. And for a reason, you're welcome to just say, because it fails the vertical line test. I should also put an "in" at the end of that function because that's going to bother some of you. So to recap, a relation is just a relationship between a domain and a range, and we can show that with all the different representations that we have. A function is just a special type of relation where each domain value connects to one and only one range value. And to see if a representation is a function, all we have to do is look for no repeating domain values with different range values. Good luck.